All right, so in problem 8, what we need to do is, if you notice, this is what we're starting with, and I need to somehow get these into identical parentheses squared, double parentheses, which means I can factor these. That might be the safest bet. I'll show the other way, and then you can combine them in one. So if you want to look at this as going from standard form to factored form, then just factor it. So first I would look for a GCF, and I can't. And then I would look, since there are 3 terms, I will make my x. And I'm going to have 100 and x squared at the top, and then negative 20x in the bottom. And if you look at your factors of 100, that get you to 20. There you are, 10. But again, to get to negative 20, not only will I have to make one 10 negative, I'll have to make both of them negative. So when I add these, I get the negative 20, and when I multiply them, I get the positive 100. So again, we're just working with this. We're just factoring it to get it into factored form. And now what I'm going to do is group these, and I'm going to rewrite them. So this is to get into factored form, and I'm going to have, well, I shouldn't have done the parentheses yet, but x squared instead of the circled, I'm going to have the circled. And now your flip book says group them, which I did. I jumped the gun a little bit, and now I'm going to do a GCF here. So I notice that they don't both have an x. Somebody's getting called here. So they don't both have an x, but or a number that I can take out. But I do notice I can take an x out of both. So I'll take an x out, and x times x is x squared, and x times 10 is the 10x. And again, these are going to have to match. And now, what times x gives me that negative 10x there? That's another negative 10. And so when you're done, if you notice, you're going to have x minus 10 for the matching, and x minus 10 for what's on the outside. So when you're done, if you look, and, you know, minus a, and I want to know what a is just 10. Now, some of you might have noticed, well, can I just go from standard form to vertex form? And that's your other option. So if you don't want to factor, you can, and you notice that's in vertex form, you can complete that square. So that's where we take our problem. I'm going to rewrite it here. And we group our x's with our blank. So we add a blank and subtract the next blank. Some of you are adding both of them. And it's x squared. We are ready to go. So you should look at this as a negative 20. If you add the opposite, you're going to cut it in half. That's negative 10. You're going to square it, and that's 100. And that goes here. And then since we're adding 100, we're going to take away 100. And first, I'm actually going to start over here. And 100 take away 100 is 0. So I actually don't even need this. And then if you remember, we can write this part as x minus 10, that number, and square it. And now if you look, I mean, you could have the 0 here, but if you notice, this matches this, and a is 10. So either way, you are able to get and figure out what that is. So do you want to look at it as if it's in factored form or vertex form? Factored form, factor it. Vertex form, complete the square. All right, a few more to do together, and then you'll be working on your own. Okay, so number 9, again, we want to determine if these are perfect square trinomials. So that perfect square trinomial follows this pattern of, if you take 6 and cut it in half, and then square it, is that the number you get here? So yes, this is a perfect square trinomial. If I factor this, I will get identical parentheses of x plus 3 and x plus 3, which is that x plus 3 squared. So just run that through here. Again, you should probably look at this as a negative 8. And just because they're here, it doesn't mean they will be perfect squares. So they're not all definitely yes. All right, so here, write each polynomial in vertex form. So remember, you've got vertex form on the back of your flip book, but it tells you to complete the square. So that's what I just did on the other page. So I'm going to group my x's. It's x squared. I'm safe. I'm going to add the opposite as I rewrite that minus 2. I'm going to add a blank. I'm going to add the opposite on that minus 8, and I'm going to subtract a blank. And so now I'm going to take this number, we're going to cut it in half, and then I'm going to square negative 1, which means negative 1 times negative 1, which is 1. And I really just have a 1 there. because there's nothing out here affecting it. So now with this part, remember, 1's done its job. This number is what's in your parentheses. You can do -1 plus -1, whichever you want. And then -8, now I'm going to, over here, add the opposite, and hopefully you see that that's just -9. And now it's in vertex form. So on the next one, when I group my x's, remember, this has got to be x squared. So there is really a -1 hanging out of here. I'm going to add the opposite here. So when I group my x's, I need to take a -1 out of the x squared. But that means I'm going to divide this by -1 so that I have a 4x here. There's adding my blank. There's subtracting my blank. So remember, there's the -x squared, there's the -4x that we started with. It just looks a little different. So now I'm going to take that 4 and cut it in half. I'm going to square it. I'll get 4 again, and that's the number that goes here. Now, it's not the number that goes here because this -1, remember, is for that -1x squared, and that's for the -4x. So when you put it to here, this 4 is really worth -4. So when I focus on this part and I go for my parentheses squared, the 4's done its job. It's going to be x plus this 2. Hopefully you remember that -1. And then 1 minus -4. Again, subtraction, negative numbers, never easy. So I'm going to add and then the opposite. So this really just becomes 1 plus 4, which is 5. All right, now if you haven't done it, do B and do D. All right, 11. So we have a rectangle. I'll draw it down here. And you are asked to find, and the widths and lengths are 2x plus 3 and x minus 1. And we have to find the perimeter and the area. So remember, is length times width. So you're going to set this up. We'll go ahead and set up as your length times your width. And hopefully you realize, oh, that's just a neighbor problem. But maybe you want to add the opposite here. But on the perimeter, what it means is there's actually, if this is 2x plus 3, this is 2x plus 3, and if this is x, again, I'm going to add the opposite now, that this is x plus -1. And so I just need to add these 4 sides. So when I add them, I'm going to do it a very certain way. I'm going to have 2x plus 3, and then I'm just going to start here and work my way around, and I'm going to stack it just below. That's like 1x. And I'm going to put that one there. And then I'm going to put this one there. Because if I do this, I can see all the like terms. So if I add the 3's, that's 6. If I add the -1's, that's -2. And if I just add those, I get 4. But I could also just do 3 plus -1 plus 3 plus -1 on my calculator and get that. Otherwise, here's 2x. That makes 3x now. 4, 5x. And 6x. So my perimeter, when I'm done, is 6x plus 4. Okay, let's go to the next page, and we're actually going to start with 13 and then move back into 12. So 13, this time I have a square, and it says that the length is x plus 5, which actually means all these are x plus 5. So this time, for the perimeter, you are going to find the perimeter where you add all the sides, and I'm going to find the area. So join me when we find x plus 5, length times width, and it's just a neighbor. So I get x squared and 5x. And then the other neighbor, 5x and 25. And then when you add up, you're going to get x squared and 10x and 25. So my area is x squared plus 10x plus 25. And then 12. So the idea is, when you do these problems, just talking about this, you need to go from standard form to factored form. So to get this into factored form, remember, you should be looking at the directions of factor completely in your flip book. And then for vertex form, to get from standard form to vertex form, you need to look at your flip book of complete the square. Okay? Now, from this, if you notice, these are neighbors. So what I'm going to do is have the neighbors meet. And when the neighbors are done meeting, that will get you into your standard form. And again, once you have your standard form, okay, so this is going to be your first step, then what you can do is use the standard form to get it into vertex form by, again, completing the square. Okay? So maybe try those first or try them now, but what I'm going to do is get this from vertex form to here. So how do I get rid of all these parentheses? Well, first I want to notice that the parentheses mean that there are 2 of them, and that I've got some neighbors who want to meet, desperately trying to meet. So when I have the neighbor of 2 and x plus 2 and x plus 2, I'm going to actually have these neighbors meet because they're so similar. So first I'm going to get x squared and 2x, and then neighbor 2 is going to visit. I'm going to get another 2x and another and 4. So when these neighbors are done meeting, I have x squared plus 4x plus 4. Now the neighbor they have not yet met, so they're all hanging out, is this 2. So now 2 wants to meet the neighbors. So I get 2x squared, I get 8x, remember we're multiplying, not adding, and then another 8. So all the neighbors have met, and now, by goodness, don't forget this negative 18. He's coming down and hanging out, and when I do this, I'll just want to see how I can clean this up, and I notice that I have some like terms of 8 and negative 18, and I can add these up so that when I'm done, my final answer is 2x squared plus 8x plus negative 10. So this is now our standard form. So I'm going to take this, I'm just putting it over here. And now the only form I need to get is factored form. And to do that, I should take this and factor completely. All right, and you're going to see how those go. And then that is your review.